Hello everybody, we're going to start today by going over some notes for algebraic equations. We just got ourselves all the way through algebraic expressions and evaluating and recognizing and writing them out. So now we're jumping to equations and solving equations. So we're going to start off with some definitions here. So we have an open sentence. So just like we said, an equation is a mathematical sentence. An open sentence is going to be an equation that contains at least one variable. So we have an example here, x plus 5 equals 20. So this is open because we do not know what x is yet that makes this true, although this one may be easy to see. There may be others that are not quite as simple. So solving an equation is when we replace the variable with a number so that the equation is true. So up above here, well, what number would make this true? Well, we know that if we take 15 and add it to 5, that is 20. So solving this, we would say x is equal to 15, which would make this number sentence here true. So the solution is any number that makes the equation true. We call this the answer, or, well, I guess the definition is solution, so it's the answer to the equation. So just like I showed above, x equals 15 is the solution. So we notice that our variable is included. We said x equals 15. So inverse operations just means the opposite here. So if we're adding, then the inverse operation of add would be to subtract. Excuse me, sorry. And if we look at divide here, at being the inverse operation, well, the operation that we started with then, that is the inverse of that, is to multiply. All right, so we have our law of equations. This is really important here. This is going to be the basis for everything for solving. So whatever we do to one side of the equation, we must immediately do the same thing to the other side of the equation. So we must be fair, and we must show equality. Or we must show, equality. So you got to show me that x equals something. So properties of equality, so used when solving equations, we have to do the same on both sides of the equal sign in our equation. So that is showing that equality there. All right. So our goal here for this example is to get c all by itself, to see what c is equal to that makes this true. So we want to get c by itself on one side of the equation by doing the inverse operation of addition, which we know, of course, is subtraction. So we're going to subtract -3 from both sides of the equation. So c will be all by itself. So we know that subtracting negatives is really just adding positives. So we are going to just simplify this a little bit. We're going to be adding 3 to both sides here. And when that happens, our -3 and our 3 cancel out, leaving c by itself, which was our goal. And then on the other side, we have 5 plus 3 gives us 8. So c is equal to 8. We must show those steps as we're working here. So next we can check if our answer is correct by plugging in the solution to the original equation to see if it makes it true. So when we take a look at this, we said that c was equal to 8. So they're plugging in 8 right there to see if it's true. So 8 plus -3, or 8 minus 3, gives us 5, and that checks out, so it works. It is true. So how do we show our work and solution on homework quizzes and tests? So we have our original problem here. We need to show the step we are taking in order to make this happen. So here we have negative 13 times s gives us negative 91. So we are dividing this side by negative 13. What we do to one side, we have to do to the other. So we're going to divide this side by negative 13 as well. So that's how we show our work. We just showed our dividing step. And then we have our solution, because negative 13s divided by negative 13 just leaves us with s, and negative 91 divided by negative 13 leaves us with 7. So that is how we are going to show our steps. And we notice that our solution is shown, so we keep our variable there too. We must show what is equal to what. So we're saying s is equal to 7. So we're going to go through these first 4 before you start your independent practice. So we must show the work in the boxes, and then we're going to put our solution up in the blank here. So let's start with this. So if we have a plus negative 5 equals 10, well, adding negatives is really subtracting, so I want to do the opposite of subtract here, so I'm going to add 5 to this side and add 5 to this side. So when we take a negative 5 and we add 5, that goes away, and that's how we get a all by itself over here. And 10 plus 5 on this side gives us 15. So our solution is a equals 15. So that's how we take care of adding the opposite or subtracting. Number 2, we have a subtraction problem here. So if I have b and I take away 6 and I get negative 15, well, let's see how we do that. We are going to, well, b is getting 6 taken away from it, so we're going to add that 6 back in order to get b by itself. Add 6 on this side. So b is going to be equal to, well, negative 15 plus 6 is negative 9. So b will be equal to negative 9. So we're just doing opposite operations here. So for number 3, I've got 5 times c gives me negative 20. So how am I going to take care of that one? Well, since multiplying is happening here, I need to do the opposite operation of multiply. So I'm going to divide by 5. What I do to one side, I must do to the other. So I'm going to divide this side by 5. 5 divided by 5 gets us our 1c, like we want to know. And negative 20 divided by 5, well, negative divided by a positive is negative, and 20 divided by 5 is 4. So our solution here is c equals negative 4. And finally here we have d being divided by negative 3 in order to get us 13. So we want to think, what is the opposite of dividing? Well, that's multiplying. So we are going to multiply this side by negative 3 in order to get d all by itself. And we also have to multiply this side by negative 3. So 13 times negative 3 is going to get us negative 39. So d is equal to negative 39. And we can also check ourselves, remember, to see if this is true. So we can plug in, just like we've been practicing before. So 15 plus negative 5, is that equal to 10? Well, 15 plus negative 5, or 15 minus 5, is 10. So we get 10 equals 10. That is true, and we know that that checks out. We can also do the same thing to each of these. Plug in your answer for the variable to see if it worked, and if you get something that is true. Up next comes the independent practice. So you are able to use calculators. Calculators are allowed for this, but you must show your steps when you are writing this. Showing steps for this is going to be half of the credit for our assignments and tests and everything. So make sure you're showing your work. Our first three problems of our independent practice are going to start on the notes page here, so make sure you remember and keep those on your paper where you are completing the rest of your assignment. If you have any questions, please feel free to send me an email. And so get working on your independent practice and make sure you turn that into the correct spot. Thank you, and we will talk to you later.